So, class, today we're going over something very simple. Very, very simple. It's called powers and roots. Do we know what powers and roots are? Powers and roots. Powers, I'm sure you've seen. They are the famous something squared, something cubed, something to the power of something. So it's like this. There are 3 squared. That's a power. Do we know what the answer to that is?
Isn't that just, I don't know if it's divided by or multiplied or if it's wrong. Isn't it like 3 times or divided by that number?
Times 2, you mean? Or
Yeah.
So close.
Or 3 times.
Yeah. There you go. The second one. So powers, it is not 3 times 2. That's wrong. Okay? It is 3 times 3. Why? Because it's the base number multiplied by itself 2 times. That's what powers are. So this one is 3 to the power of 2, which means you multiply 3 by itself 2 times. Now, there is a nickname to the power of 2. Do we know what it is? 3 to the power of 2, what is that called? A little shortcut, a little nickname for it. It is 3 squared. So anything to the power of 2 is that number squared. Four squared, which means 4 times 4, which is 16. By the way, the one that we just did, the 3 squared, 3 times 3, 9. Does that make sense? Pretty straightforward. What is 3 to the power of 3? Well, all it is 3 times 3 times 3. What does that become? Well, ask yourself this. What's 3 times 3? Then ask yourself, what's 9 times 3? Close. 27. That's 3 to the power of 3. 3 times 3 times 3. 3 times 3 is 9. 9 times 3, 27. That's how you do that. Huh?
Not technically.
Not technically. It's technically 9 times 3? Or... Exactly. That's the beauty of powers. And that's something you got to keep track of. It's 3 times 3, whatever that answer is, times 3. So numbers could get pretty big pretty quick with powers. It could get extremely big. Just like the squared, this one has a nickname. Something to the power of 3. What's the nickname? If something to the power of 2 is squared, that same number to the power of 3 is cubed. cubed. So if you ever get a problem like 16 cubed times 6, right? It's pretty much 16 cubed, so 16 times 16 times 16, whatever that answer, times 2, or whatever the third number was that I said. Something cubed, something to the power of 3. And obviously the pattern goes on. That same pattern could go on for any number. 5 to the power of 4. What's 5 times? What is 5 times 5 times 5 times 5? This is an example of how big numbers could get when powered. Let's do this. What's 5 times 5? Then ask yourself, what's 25 times 5? This is big. This is going to be a huge one. 125. Then ask yourself, what is 125 times 5? $625. The answer is 5 to the power of 4 is 625. Did you guys see that? A lot of math. Huh? Really? Tell me, why is it confusing?
Because it seems like it should be 5 times 5 times 5 times 5.
Well, what is that?
25 times 5.
Well, exactly what you said, the same thing you said, it should be 5 times 5 times 5 times 5. That is that. This is visually just how it is. If you did it on the calculator, 5 times 5 times 5 times 5, it does that. That's how it just operates behind the scenes. You don't see it, but that is how it works. It is 5 times 5 times 5 times 5. It's just that the calculator just dishes out the answer, right? How do you do it by hand? Step by step by step, just like that. Those are powers. Do we have a nickname for this one? 5 to the power of 4? The answer is no. It does not have a nickname. It's just 5 to the power of 4. From 4 and above is just to the power of. So it's 5 to the power of 4. 5 to the power of 5. 5 to the power of 6. Doesn't have no more little nicknames, little cute nicknames that was given to it. No. It is now just to the power of. But there are some powers you have to watch out for, okay? So this is where it becomes interesting. Some stuff that you might want to write down for the quiz and for your guys' own sake. Because again, you're all taking your GEDs. Huh?
All 2 of us.
All 2 of you. There are some tricks, okay? Anything, any number, whether it's 8 or 3 billion, anything to the power of 1, what do you think it is?
Itself?
Yep. Itself. Just the base number. That's trick number 1. Trick number 2. Anything to the power of 0. What do you think it is? It doesn't matter if it's 6. It doesn't matter if it's 5 billion. Anything to the power of 0 is what? If you guys had to guess, all 2 of you, what do you think it is?
0.
Okay, what do you think it is?
0.
Okay. Anything to the power of 0, have this in your head or write it down, is 1.
What?
Yeah, I know it doesn't. You guys want to ask why, don't you? It's at the tip of your tongue. Trust me, you don't want to go down that rabbit hole.
It's technically, okay, wait. Because it's 0. No, oh my gosh.
Exactly. Exactly. You do not want to ask
I
why.
was going to say because it's 0 and 6, but that would make it 6. So.
Yeah. Everyone always gets confused by this. It literally doesn't matter if you have such a complicated problem. Like you could be given a complicated problem like this. Do you know what the answer is? 1. Do you see that? Whatever all of this became, doesn't matter what the answer is of everything that's inside there. If it's to the power of 0, guess what the answer is? 0. That's the beauty of this trick. And then my friends, those are the only 2 tricks you need to know for now. Anything to the power of 1 is the base number, the number itself. Anything to the power of 0 is 1. Okay? So, what else could I teach you about powers? What else do y'all want to know? Nothing? How about we move on to roots? Roots, my friends. That's the famous sign like that, right? The beauty about roots is the roots are the distant cousins of the powers. They are very, very similar. They are related to each other. So for instance, it's almost as if you're working backwards. Have that in your head. You are asking yourself, you are technically asking yourself here, what number, when multiplied by itself twice, creates 9? That's what you're asking for. So you tell me, you guys, what number multiplied by itself twice creates that number 9?
Is that the same for every problem with roots?
What number multiplied by itself twice creates that inside number? Yeah. 3 times 3 equals 9, right? So the square root of 9 is 3. So it's almost as if you're working backwards, because before we were doing this. Before we were given what's 3 squared. And then we said, oh, 3 times 3 times 3 equals 9. Wait, that's wrong, sorry. 3 times 3 equals 9. I said 3 times 3 times 3. That's wrong. 3 times 3 equals 9, right? If you realize when they're giving the square root of it, it's almost as if you're working backwards. What number times itself? You're pretty much asked to look for that base number. What is that base number? You don't know what it is, right? And then you do the math. What number multiplied by itself twice gives it 9? Well, it's 3. Now, square roots are very interesting, though. Okay? It is very, very, very interesting. because of something called, let me write it down for you. The perfect squares. The perfect squares, my friends. What does the perfect square mean? Well, let me show you. What number multiplied by itself creates 9? Well, we know that it's 3, right? So pretty much 3 times 3 equals 9. What's the square root of 9? 3. That number right there. Ask yourself, let me move this down a little bit. Ask yourself, 2 times 2, what is that? All right, what is 4 times 4? What is 5 times 5? Well, let's just stop there for now. So if you notice, these numbers are the perfect squares. So if you were to ever be given a problem like this, what is the square root of 25? What is it? 5. So, if you notice, these are the perfect squares for these numbers. Which means if you were to be given something like this, what is the square root of 7? Do we know what number times itself twice creates 7? It does exist, but guess what, you guys? It's a long decimal number. Do you guys really want to know what it is? You can't even solve it unless you have a calculator. It is 2.645751311. If you were to get that number and multiply it by itself, so 2.645751311 times 2.645751311, yes, it would come out 7. But guess what? This 7, the square root of 7, is not a perfect square. It is not here in our list. It is not a perfect square because the number is a decimal. The square root of 7 is a decimal, right? That's not a perfect square. These are called perfect squares because guess what? They come out whole numbers, right? What is the square root of 4? 2, a whole number. What is the square root of 9? 3, a whole number, right? So this list could go on forever. This list could literally go on for a long, long time. What's 6 times 6? What is 6 times 6? 7 times 7? 8 times 8, this is the famous one that everyone always remembers. 64. 9 times 9? Let me write it out first. Okay, 9 times 9 equals 10 times 10. Everyone likes that one, 100. And I'm telling you, this could go on forever. 11 times 11, 12 times 12, 13 times 13. For infinite, because numbers are infinite, right? We could go to 1 billion times 1 billion, right? But keep in mind, those answers are your perfect squares, which means you could be given something like this. What is the square root of 81? Exactly. If they were to ask you, what is the square root of 82? Guess what? You take out the calculator because you can't solve it any other way. Right? There's only a select few of perfect squares that you're going to be given. So my suggestion to you is to memorize those perfect squares. Memorize 7 times 7 equals 49. 6 times 6 equals 36. 5 times 5 is equal to 25. 8 times 8 equals 64. Memorize that. Because if you're ever given a square root of something, such as this, what's the answer? What's the square root of 49? There's only a few that you guys have to memorize. I always tell my students, memorize up to 15 times 15. Just to be safe, right? So what's 11 times 11? 121. So 121 is another perfect square, right? Tell me, you guys, what's 12 times 12? 144. 13 times 13? 169. 14 times 14? 196. And then 15 times 15 equals 225. These are 15 perfect squares. Like I said, there's infinite. There's an infinite amount of perfect squares, but only a good chunk that you need to memorize. So if I were to say, what's the square root of 169? What's the answer? Exactly. You see that? The square root always intimidates people. They always see that little square root sign and they're just like, how the heck am I going to memorize this? If they were to have just remembered 10 or 15 of the perfect squares, they would know whether they'd know the answer right away, or they'd know, hey, I got to take out the calculator because I can't solve it any other way, right? But these are 15 perfect squares, and it's your job to memorize them. Tell me, you guys, what's the perfect square of 121? What's the square root of 121, I should say? 11. What's the square root of 64? That's all it is. If you're given anything else other than those perfect squares, anything else like the square root of 56, guess what? You got to take out the calculator. And you do the square root of 56, do you guys know what you get? Don't know what we get? Don't know what we get? 7.483314774. Right? That's a decimal. It's not a perfect square. The square root of 56 is not a perfect square. So do we understand square roots now? Do we understand? Do we see how it's similar to the powers, except we're kind of working backwards? They're cousins. These are the stuff that's important to memorize. And, by the way, it also makes you look really, really cool in front of people. When somebody asks you, what is the square root of 225? You could be like, 15. And they're just like, really? Let me check. And then next thing you know, you look cool in front of them. And you could also be cool by telling, if somebody tells you, what's the square root of 216? You could be like, it's a long decimal. Solve it with your calculator, because not even Harvard graduates could solve those unless they have a calculator. I mean, geniuses could probably do it. They see numbers like no other person does, right? But, no. You can't solve the square root of 216 unless you have a calculator to do the math for you. These are your perfect squares. I suggest you memorizing them. Up to 15, just for your own sake. Yep. Are we ready to do a worksheet? Powers and roots. Let's do this.